Do you need a straw?
Yeah.
Do you need a bib?
No, I need.
No? Okay.
Anyone have tissue?
Tissue? I have tissue. Yeah, I have.
Where did you spill it?
My.
Oh, what? My bag, come on.
Like,
So messy, so messy. I don't think the boys in the class are this messy. So messy. Sean has food and coffee every day and he never makes a mess.
Huh?
You're always so clean, you never make a mess.
I'm a very clean person. Ask his Larry, he went to my room.
Oh! Please, amazing! Amazing! No, yes, we know, yeah, we got it. Oh, yes.
Continue it.
Yes!
No. He's a minor. He's a boy.
Yeah,
No.
that's what I'm talking about.
No, this would be quite inappropriate.
Yes,
No.
but she's not.
I'm sorry.
Interesting.
What?
You guys are so dirty. So dirty.
Yeah, so dirty.
But how is so clear? I don't
Yes.
know about that
Yes.
thing.
Yes.
But we know.
Yes.
Even though I have
We know what happened.
But even though I have
You guys are dirty. Leave Jerry alone. It's okay, Jerry. It's
What about
okay.
me? Why are you doing
Continue it.
Everything's recorded. Is that lost, alright?
No problem. I can stop this and delete it. It's okay. all right.
No,
You
I
continue.
took a lecture that I missed.
Yeah.
And then I hear everything you guys say about.
That's okay. We're all friends. There's no secret.
Jared.
Do you want me to delete it?
No.
Jared, it's okay. All right.
No, everything.
Let's continue, Sean.
Okay.
Potential divider. Did you write that down? Yeah, study. Potential divider. Study, potential divider. Okay. You got that? Potential divider? Alright, let's have a look. So this is the last topic in electricity. And again, a little bit like the last lesson, we can use some Kirchhoff in it. Okay, so let's have a look. Did you get that, Sean? Come on. Potential divider.
So consider too much about this.
Yeah. Focus on physics.
Yes.
Yeah, okay, fine. Ready?
Yeah.
Okay. Now, let's have a look at this circuit here. Again, this is another important circuit. In this circuit, we have R1, which we can change, and R2, which is fixed. We have a voltage that goes in from a cell, and a voltage that we measure on the R2. Okay? And let's see what equations we can make. Again, let's use Kirchhoff. So let's use the loop rule. And I think we'll get Bruce. We'll have Bruce using the loop rule. So Bruce, start here. Use the loop rule. What can we say? This is V in. And we'll go this way around, okay?
Okay.
So V in. Yeah. Yes.
Minus
Yeah.
IR.
Yeah. 1.
IR1.
Yeah.
Minus IR2.
Good. Equals 0. But we actually know the voltage here. What's the voltage here?
V out.
V out. So, anyway, as Bruce said, we have V in minus IR1 minus IR2 equals 0. And we can rearrange that to get the I. I is V in over R1 plus R2. Yep. But we have a formula for voltage. Voltage is IR. So this V out here, this V out is IR2, which is equal to this. So in other words, we can easily, again, by using the loop rule, we can easily get this formula for V out. V out equals R2 over R1 plus R2 multiplied by V in. That's an important result. So can you write this little proof down? So again, we're just using Kirchhoff's loop rule. Oh, did you see my reply to your comment?
Yeah.
Okay.
Okay, good.
I'll do better next time. Bruce, did you get my reply to your comment?
Hmm?
You posted a comment on YouTube.
Yeah.
Did you see what I said back?
No.
Ah. You posted, what did you post?
It's my name.
And what do you think I replied? My name.
Okay.
It's not funny.
That is funny. I liked this comment as well, I think. Huh? For the views, for the hits. Well, I have I have 216 subscribers.
Yeah,
Can't you make like fake email and then go to subscribe?
Oh, like spam.
Don't you have program like to create email?
I write a spam program. Please subscribe to my YouTube channel. That's sad. Alright.
I mean fake subscriber. Use those emails to create.
I could actually do this.
But is there any like authorization for the email stuff?
Yeah, the problem is to make a YouTube account, you have to have a mobile phone number, which makes it a bit hard. So what I usually do when I make what I usually do when I need to make fake accounts is I pick up a free SIM card. I have my reasons. You know, because when you subscribe to something, they usually give you a free trial. You know, if you use your Facebook or your Google account. But to make another Facebook or Google account, you need a phone number. So the way I see it is when people give away free SIMs in shops, each one of them is like getting a free subscription to something for a month. So they have a value. You know?
Teach us.
Oh, you will learn in time. Okay. Did you write that down?
Yes.
Right. So, this formula I have here, the reason this formula is useful is because it lets you change your voltage. If you think about it, if you have some voltage here, let's say this is like 9 volts, and this here is, you want it to be 1 volt, and the R2, if we look at the circuit, maybe the R2 is like a mobile phone or a laptop or a light bulb, so this could be R1, and maybe R2 could be like a light. Then we cannot change the we cannot change the R2. That is fixed. And we can't change the voltage that comes in. That's a problem. That's fixed. And this is maybe something that we want. But we can change the R1. So if this is too big, what can we do to the R1? No, increase it. Or sorry, increase it. Because 1 over a big number is equal to a small number. And a small number times 9 would be smaller. Yes. Yeah. So basically this here can let me change this. Now, the potential divider is a very simple circuit. It has a disadvantage though. The disadvantage is we can only make voltages which are smaller than what we began with. We can't use this to increase the voltage. This is a disadvantage. Later we will learn how to do that, but for now we can only make it smaller. So, the potential divider, what exactly is it? It's a simple circuit that lets you reduce the voltage. And you can find the voltage from the output by using this formula. So, note this definition, please. Okay. Do you have that?
No.
Not yet. You have that? Yeah? What's wrong?
Awful.
It's too healthy.
Stick to the frappuccinos.
See, Mandarin rather than green tea and vitamins.
Sounds nice. Alright, have you got that, Bruce? Not yet. Andrew, you have that? Yeah. Come on, Sean and Bruce. We're all waiting for you.
I got it.
Okay, Sean, come on.
Don't worry.
Don't worry. Can I continue?
Don't worry. Okay.
Yes? Alright. So, I am very happy. Let's have a look at our first example here. A circuit requires 11 volts. So here's a real example, okay? Look here. These are providing 220. 220, yes. But maybe something like your laptop or your phone or whatever, that only needs 11. So if you connect this directly, that's too much. It's too much. So in this picture here, you've got a supply, and this is 220, we'll say. And here is a resistor that you can change, and here is a small resistor, 10 milliohms, we'll say. 10 milliohms. And we would like the voltage here to be 11 volts. And this one here, we can change it, so we'll call it X milliohms. And the question is, what should we make it so that we get the 11 here for our small resistor? What should we make it? Okay, so we can just use our formula to begin with. First, A is to draw. Okay, so I've drawn it. B, find the X. Okay, so our formula is 11
Yes.
equals R2. That's R2, isn't it? Over X plus...
R2. R2.
Yeah, actually, you know what? And I'll put X in ohms. 0.01 times 220. Okay, so let's solve this. That would be X plus 0.01. 220 divided by 11 is 20, isn't it? So that'd be 0.2. I think. Am I doing this right? X is 0.1. No. 0.19. So that's 190 milliohms then. That's the X. So that's how much we should make the X then. Okay. Now, this is, I suppose this is now the next part. What's the current? And then on to the interesting part, the current. Okay, so let's imagine we put an ammeter here. This is for part C. Well, we have V equals I or, V I or. The I equals V over R. Now, do we know the V? Well, it depends where we're looking.
We can use that directly.
I want to know what is the current. Yeah, so I could look at this one actually, because I know the V and the R, so that would be I equals V over R 0.01, no, 11 over 0.01, V over R. What's that? Is that 1100 amps? That's freaking huge. Did I do that right? V over R.
Just the resistor.
It's so small.
Yeah, so small.
Okay, fine.
It can't have 11. Yeah, it can be 10. 10
Boom. Right, that's a frickin' big current. But of course, this is the point I guess I'm trying to make when I made the question, because in real life, what happens is the resistor isn't this small, like 10 milliohms is tiny. What usually happens, I don't have it here, oh no I do, I can show you on my, yes. So what usually happens, you have some circuit that takes in the 220 and it comes out here at 11. Now, what will happen is you have the little resistor here that you can change, and then you have the small resistor here. Then you connect like your laptop to this end. So in the picture, what will happen is here, yeah, you connect your laptop. Whoa. So a big resistor goes here now. That's what happens. You connect a big resistor. Because if you think about it, you can't change the small resistor here, and you can't change the variable resistor because this is all set in the factory. So you know when they're making this, they adjust it. Now what's really smart though is this can adjust automatically. So for example, if I plug this into a 110 in America, then the resistor here, the X, this will change automatically. You know, I go to another country, it will change automatically. So these are made to go between values, like say 110 and then 220. Something like this, which makes it very useful. So this can change and this cannot change, and this will change to fit this. But then this here, this resistor is quite large that you've now connected at the end. Okay? So by large in this example I mean 2 ohms. So let's imagine now we connect a 2 ohm resistor. So for part D, I want to know what is the voltage here in part D. Okay, so we want to know what is the voltage here. Well, we know the total voltage here is 220. If we knew the voltage here, we could know the voltage here. Why is that? Well, because the 2 should add to make 220. Okay, so I could say 220 equals this plus this. But then you realize, well, hang on. If I add these two together, so it's like this, you know, if I put these two together as one, then what circuit have I got here? I have the same. I have a potential divider. And so I can use this formula again. So what we'll do is we'll add the two together to make 1 here. Okay? So that's 1 over R equals 1 over 2 plus 1 over 0.01. Okay, so that's 1 over R equals 0.02, 2.01. So R equals 2.01 over 0.02.
No.
That's not it. What? I just wrote the same thing, didn't I? 0.02 over 2.01. Okay, what's that, please? Okay, 0.0095. 995. Okay, so now if I use my voltage formula here for V out, I get V out equals, yeah, 0.00995 over now I didn't say this in the question, but we imagine the X has stayed the same, so the X plus the R 0.19 plus 0.00995. Okay, what's that, please? If you can hit that in. oh yeah, sorry, times 220. What do we get?
10.95.
Now, what do you notice about this answer? It's
No.
very similar to the previous answer. And this is the reason, Jerry, this is the reason I use a small resistor. Because if I use a small resistor and then in parallel connect a big resistor, the voltage will still be about the same. So my point is, I can use this circuit to change 220 into 11 by connecting any big resistor to it. It should work for laptops, phones, TVs. There'll only be a problem if what I connect is too small. But if I connect a big resistor, like a laptop or a TV, then it will always change 220 into about 11. Yeah? Do you understand?
So the S value is fixed.
Well, it's fixed for us, but in real life, what will happen is it'll only change if you change the input. So if I go to a different country and plug it into 110, the X will change. But it will not change if I plug my laptop in, maybe. Because you can see, if I use a 2 ohm or 3 ohm or 4 ohm, I'll probably still get about 11 volts. Yeah? So that's the potential divider. So it's just the one formula which you get from Kirchhoff. I'll give you the questions now. You have 2 worksheets, and then that's it for electricity. I need to make the answers, but if you had some trouble, we can do it today in the tutorial anyways. Okay. So if you can take one and pass it along. Thank you.
You are tutorial is for physics or math?
Physics.
Physics. How about that?
We'll do maths on in the maths class. Yeah, that's a good idea actually, Jerry. We'll do maths in the maths class.
Very.
Do you have more math language? I don't want
See? Okay. Yeah, one each.
What do you know?
Okay, you can start these for a few minutes, okay?
Can we go now?
No, you can't go now. It's 10:33. Try these for 10 minutes at least. It's not going to kill you.
I should go to get coffee.
No, you can get it after class.
We can talk about finger.
No. 10 minutes, please.
Go to learn biological. Don't
Yes,
say-
exactly. We're in physics. We're in physics.
Can you upload the video? Are you uploading that right now?
I'll upload it right now in a second.